This is Unit 4, Day 3. We're starting off with vertically and horizontally stretching and compressing functions. Okay, so if you're stretching the function, think of that you're pulling on the parabola. If you were to stretch it, it would be getting narrower. And then a compression would be pressing on it from up and down, and then that would be getting wider. Horizontally stretching it is getting wider, but horizontally compressing it is getting narrower. So that's a little bit, they're opposites there. Okay, example 12. Consider the quadratic function f of x equals x squared minus 4x minus 5. The quadratic function g and h are defined by the formulas 2 times the function f of x and h of x is equal to 1/2 the function of f of x. Okay, determine formulas for both g and h in simplest trinomial form. Don't forget parentheses mean to distribute. Okay. So for the g of x, okay, so looking up here, it means it has to be 2 times that whole function. So it's 2 times x squared minus 4x minus 5. You distribute that and you're going to get 2x squared minus 8x minus 10. Okay? All right, h of x is equal to 1/2 times that whole function, x squared minus 4x minus 5, which results in 1/2 x squared minus 2x minus 5/2. Okay? Just distributing 2 and 1/2. All right, using your calculator, sketch and label each curve on the set of axes given by plotting each of their turning points and zeros. So if you guys pay attention to that, it gets a little bit funky, so just look for the turning points, look for the zeros, and you know you can use your analyze graph to find the turning points and the zeros. Okay, so it gets a little bit ugly here, so this is what I do. Half of negative 20 would be negative 10, and half of negative 10 is negative 5, and this would be negative 15, and then you have all your in-between. So this would be negative 11, 12, 13, 14. This would be negative 6, 7, 8, 9. Negative 1, 2, 3, 4. So that helps me with my graph right there as well. Okay? What did I do wrong? Did I do something wrong? Oh no, this would be 16, 17, 18, 19. Okay. All right, so now just taking the time to graph everything here. So my f function, which is the original, I'm forgetting where everything's going. Okay, so it looks like, negative 9. Okay, so we're at 2, negative 9 for my g function, and my x-intercepts or my zeros are at negative 1 and positive 5. So now if I do a little freehand sketch of that, and that one hit, hopefully, oops, nope, I'm a little off. It's supposed to hit at negative 5. And then there's another one at 4, negative 5. Just to kind of keep things symmetric here. So this one's going to do this. That's my f of x. And this one has my y-intercept over there. Okay, now I switch colors and I'm going to do g of x. G of x, just your turning point shifted down to negative 18. But it's still in line here. And it has a y-intercept over here, which means it would be symmetric over here. And guess what? The zeros are in the same spot. So hopefully you're noticing that the x-intercepts are remaining the same. Okay, and my last one here is h of x, and that is down very low right here. And then I'm at here and here. So my turning point was at negative 4.5, but these are at negative 4, so they're just a half above it. And then again, you still have the same exact zeros there. So there's this one, you can see it's getting wider. Okay, so look at the differences of the colors. So My original graph f of x is the black one. And then all of a sudden when you multiplied it by 2, it's getting skinnier, okay? It's a stretch, it's closing. So the red parabola is showing it's closing. And then the blue graph, which is h of x, is multiplying it by a half. So it's compressing it, it's putting pressure, so the parabola is getting wider, okay? Part C, using the minimum command on your calculator, determine the minimum. So this one falls at, ooh, sorry guys. This one's at -9, this one's at -18, and this one's at -4.5. And again, I use that to actually graph them to get my turning points. What is really being multiplied by 2.5? Okay, all your y values. Okay, so just your y's are changing. Okay, that's why the parabola shifted up and down, because your y values are changing, but look, your x's didn't change. Okay, what points did not vary when f was vertically dilated by the factors of 2.5? I just answered that. Your zeros, your roots, okay, your x-intercepts did not change at all. Why? Because the y value is 0. So when you multiply anything by that 0, it ends up staying there where you are. So part F, how would you describe the visual difference between F and G and between F and H? So remember, we just said that. G gets narrower. It's closing. So that is a stretch. That's a vertical stretch. And H is getting wider. So if you're wider, you can think fat. If you're narrower, you could think skinny. Okay, it's closing. Okay. All right, so basically this next little blurb down here at the end of the page here says the function h of x is equal to k is a vertical stretch. So just pay attention to that. So when you have a number on the outside and k is greater than 1, it's a vertical stretch. So think of your whole numbers. So in this case, it was 2. So you're multiplying it by 2. You're multiplying it by 3. You're multiplying it by 4. Now this next little blurb says it's a vertical compression when it's between 0 and 1, which means you end up with a fraction. So if you're multiplying it by a fraction, it's a vertical compression. All right, example 13. If the point -3, 12 lies on the graph of the function y equals f of x, which of the following points must lie on the graph of y equals 3 f of x? Okay, so now remember, guys, your y values are changing, okay? So you're really just going to multiply your y. So y values change. And in this case, you're multiplying your y by 3. So up here, 12 times 3 would be 36, so that's why it's choice 2. So x stays the same, but your y is getting multiplied. Okay, for 14, the graph of y equals f of x is shown below. Consider the function y equals g of x to be defined by. So we got a lot going on here. So we are going to times it by 2. Now remember, your y value gets times by 2, but then we're also shifting it down 3. So what I did was I go to this graph here, and these 4 definite points that are on my graph, and this is f of x, I'm going to write them off to the side. So I'm going to write -2, -6, -2, -3, +2, 2, 1, and 5, 5. Okay, so again, I just copied what all these points were that were given on the f function. Now remember, this means I'm going to multiply my y values by 2. So when I multiply my y values by 2, I'm going to end up with -6, -4, -3, +4, +2, 2, and 5, 10. But then, because of this, then I have to subtract 3 because I'm moving down. So I'm going to subtract 3 from all my y's. Okay, because remember, all these changes are happening to the y's. So I'm going to end up with -6, -7. I'm going to end up with -3, 1, 2, -1, and 5, 7. Okay, so now I know it's not till later, but it does ask you to graph them eventually. Okay. It says, what 2 transformations have occurred to graph it? Well, don't forget, it's a vertical stretch. by 2. So when you multiply by 2, you're stretching it by 2 because it's a whole number. So it's considered to be a stretch. And then down 3. Okay, you could say vertical shift down 3 as well. So now when I do all those points, now it's really easy for me just to plot all those points. Okay? So here's one of them. And as soon as you make 2 points, it's very easy just to connect it so that you don't get lost with a whole bunch of dots on your paper. And that is my g function. Okay, now I know I did all the work up here, but this next part, part B, that's what it wants you to do. So it's saying to find like g of negative 3, which would be 2 of f of negative 3. 2 times f of negative 3. Okay, so then minus 3. So that is going to be 2 times, and then if you go to your graph, f at negative 3 is 2, and then minus 3. So I'm just showing all the algebraic work, and you end up with 4 minus 3, which is 1. Okay, so then watch. G of 2 would be 2 times f of 2 minus 3, and go to your graph. F of 2 ends up being 1, but then you're going to do 2 times 1, which is 2, minus 3, which is negative 1. So it's producing, guys, it's producing the same thing that I did up here, but it's just doing it in a table method, where to me, it was easier because I just multiplied everything by 2 and then subtracted 3. So, I mean, you could finish up this last one here. So g of 5 is equal to 2 times f of 5 minus 3. Then you go to your graph, and f of 5 is 5, and then you minus 3, and 10 minus 3 is 7. So those are all the coordinates that we get. All right, example 15. The function h of x has a range, so pay attention here. A range given by the interval of 2, 10. The function f of x is defined by 3/2 h of x plus 8. Which of the following gives the range of f of x? Okay, so now you're going to take 3/2 and you're going to multiply by the 2, and the 2 came from right here. It's the first coordinate in your range there. Okay, so 3/2 times 2 is 3, but then don't forget I have to add 8 to that. So this is me doing the vertical compression. So I'm multiplying 3/2 times that 2, which came from here, and then I'm adding 8 to it, and I get 11. Okay, and I'm going to do the same thing again, but with the number 10. So 3/2 times 10 is 15, but 15 plus 8 is 23. So now I ended up with 11 and 23, which is choice 1. All right, last example here. If the quadratic function g of x has a y-intercept of 12, which of the following is true about the function h of x equals 3 g of x minus 5? Now remember, you're doing 3 times the y, okay? So 3 times my y-intercept, which is 12, so 3 times 12, but I still have to minus 5. Okay, so I get 36 minus 5, which is 31. So the new graph is going to have a y-intercept of 31, which is 4.